limit is just telling us the exact value. You know, when we have functions, limit involves functions. We've talked about functions. See, look at this, guys. Function, mapping and function. This is X. This is Y. This is just a bonus for those of us that are here already. Please, is this marker showing very well? I believe so.
Yes, very clear.
So now, I have X, Y, Z. X, Y, Z. And here I have 5. I have 6. I have 7. So let us quickly note this before people start coming in. So now, I have this now. Well, I have there is a relationship between this. I'm calling it F. So what I have here now is that this is the domain, the codomain. So I have F of X. That means the image of X. This is the function, F of X. The image of X gives what? Y. So now the relationship is, this is, let me use a one-to-one mapping. This one to this one, and this one to this one. This is a one-to-one mapping. So now look at it. X goes to 6. So I can say F, which is the relationship. And even it is G, then it will be G. So I can say F of X. So F of X equals, it goes to 6. 6. This is Y. So I'll say F of Y equals, it goes to 5. 5. This is Z. I'll say F of Z equals 7. It goes to 7. So this is just what function means. Mapping and function. This is it. So it's actually not what we're treating today. It's just something I want you guys to know again. So this is how exactly the thing comes. So when you now have that F of X equals to 2x squared plus 3, just know that what we have here is actually 2x squared plus 3. That's just how it is. Don't be confused in any way. And we mentioned that if Y equals x squared plus 3, to know if Y is a function of X, then one value of X must give us one value of Y. Now let us try it. I'm going to say Y minus 3 equals x squared. So X equals square root of Y minus 3. And I have plus or minus. You can see we have two values here. Having two values definitely means there is a problem. So it is not a function. That's what it is. So I'm not using the time of what is actually not what I'm treating tonight. Here now we'll be talking about limits. We'll be talking about limits. So shall we move on now, guys? Class, everyone, shall we start now? Exactly now, clock's up. Okay. All right, now he said when we mention limits, when we talk about limits, it is just the minimum or the maximum value particular function. You know, there is always limit for something that is not bounded. For an unbounded function, there is always a bounded function, there is always limit. It is when it is not bounded that it becomes infinity. So far it is bounded, then there is always what we call limit. So we are working with that now. Not to talk too much on it, we have several types of limits. And I want us to know that we have different distance too. We have different identities. So those are part of the things you guys might pass through later. So yeah. So we have the trig ratios. Is there anyone that can tell me the trig ratios here? That's why I said today's class is going to be a good one, because I intend to let us enter some other parts which are just, understand, branching. We'll be branching at places that could be beneficial and that can come out of our exams. So anyone with trig ratios, what are the trig ratios? Anyone? Is there anyone? The trig ratios. Anyone, please, I don't like the silence. This is too much. Okay, nobody. All right. When we talk about the trig ratios, it's what you guys already knew. You knew it very well before. I don't know why you think you don't know it. The trigonometry ratios are just three. You have sine theta equals, or a right angled triangle. This is theta. This is theta. This is the opposite side. That means what opposites it? Let's call it x. The longest side is y, and this side, the remaining side will be z now. But let me say this is y, and let me call this one z. So sine theta using sine theta exactly means means opposite over hypotenuse. What is opposite? X over what is hypotenuse? Z. This is a trigonometry ratio. K means cos theta equals adjacent over hypotenuse. Adjacent is y over hypotenuse z. Is another trig ratio. Another one is tan. Tan theta equals TOA. That means opposite over adjacent. So TOA. Opposite is what? X. Over adjacent is what? Y. Please, did we all get what happened here? Should we go, Jaco show? Did we all get what happened here? All right. So it's better, please. Everyone should be showing with this emoji if you are moving with me once I ask. So now, other things I want us to be noting. Theta. Are we together? So look at something. Tan theta is, let me say my theta is, I just want to show you that this is the theory and this is very right. So tan theta equals, let me say my theta is 45 degrees. So tan 45 degrees equals what? Sine theta. You know tan 45 degrees equals 1 when you use your calculator. So sine theta, that means sine 45 degrees over cos 45 degrees. When I'm becoming too fat, please call me back, please. I really want everyone to understand today. Go. Sorry, go in the end. Sorry, I think I'm receiving a call at the moment. Danny, Kausa, Shukra. Yeah, call. Sorry, okay. Sorry. Okay, so tan theta equals to sine theta over cos theta. So 1 over, there is one thing we call, we have cos theta, we have tan theta, we have sine theta. So there is one thing we call cosec theta. Cosec theta is exactly cosec theta. It's exactly 1 over sine theta. Don't forget. Tan theta too. So cot theta equals 1 over tan theta. So these are the trig ratios. We still have more. We still have more. But for the trig ratios here, these are what we have. Please, are we moving together? Just with an emoji. Are we moving together? All right. Mr. God Slow, Abi, let's hear from you. God's love, please. Let's hear from you, God's love.
Sorry,
Naomi,
it's a mistake.
Naomi, what's the issue?
I don't know if it was my network or yours. I wasn't hearing what you were explaining before.
It's not mine. It's never my network. I said we are given the trig ratios. These are the trig ratios. These are the trig ratios, not trigonometry ratios. Cosec theta is the same as 1 over sine theta. Cot theta equals 1 over tan theta. And sec theta equals 1 over cos theta. These are the things you should just know yourself. Write them down and memorize them immediately after the class or something. I even memorize them straight down. So now, we have what we call the trig identities, trigonometry identities. If you look at the material, I don't know, I glanced through it, I saw something like this. I'm not really sure, but I passed through something like this. So I believe they will come out of the exam because of their nature. Yeah. So we have what we call the trigonometry identities, about just 3. And that's where I'm going to stop. I won't do the sign A plus B and B. So we have that the first identity is that sine square theta plus cos square theta identity 1. Please, are we together? So sine square theta plus cos square theta equals 1. This is the first trigonometry identity. That means sine square theta equals to 1 minus cos square theta, as we all see, or as we can all see. So now another one is cosec square theta equals 1 plus cot square theta. Sorry, this is the third. Sorry. The second is sec square theta equals 1 plus tan square theta. Second trigonometry identity. These things are what you should know offhand by yourself. So, and the last one here is cosec square theta equals 1 plus cot square theta. That's the third. Don't forget that cos square theta is going to be what? Sec theta is going to be 1 over cos square theta. Don't forget. And cot square theta. And cosec square theta is 1 over sine square theta. Do not forget these things. Please, is there anyone moving with us? Just with an emoji, it's okay. No one seems to understand what I explained. Anyone there? You guys should respond. Please respond. Respond. If you don't understand, let us know. If you understand, let us know. When it's too something like this now, we'll be becoming Prodigy.
Yeah, good evening. The cosec square theta, is it 1 plus cot square theta or 1 plus cos square theta?
Cot. It is cot. So that cot is exactly 1 over tan theta. Yeah. Cot theta is exactly 1 over tan theta. So cosec square theta is 1 plus cot square theta. This is already cos square theta. Cos square theta plus sine square theta will give us 1. You get it, my bro? All right. Okay. So we'll enter the limit now. No enter limit too. No enter limit too. But we'll look at limits now. So let's take it. I'm going to rub this up. Hope we've all gotten it down. Hope we've all put it down. The trigonometry ratios and the trigonometry identities. So now looking at the limit we're talking about. I said this is an example that says find limit of x to 4 in the expression, which is x raised to power 2 plus 4x plus 3. Please, you were in the last class. Please do this now. Sumabe. You were in the last class. Please do this now. Or you were not even there. You already know how to do it. So it's those that are unable to do it. We'll just explain it to the fast mode. X squared plus 4x plus 3. Limit x to 4. Are we making attempts? Nobody will answer. That's what I hate. When someone talks, at least respond at least. Don't go say anything. All right, is there anyone that has gotten the answer? We have limit x squared plus 4x, limit x squared plus 4x plus 3. All right, I get this. Let's move. Since 25. X is 4, so x squared plus 4x plus 3 is what we are taking. So x squared plus 4x plus 3, just come and take the value of x. They are saying you should limit x to 4. So x to 4 now, just evaluate. I will have 4 squared, that's 4 squared, plus 4 times 4 plus 3. That means I'm doing normal evaluation using the value of x to represent x now. The limit using it to represent x. So it's going to be 4 squared is 16 plus 4 times 4 gives 16 plus 3. So this is going to give me 35. Therefore, the limit is 10. Please, I don't understand. Show with an emoji. I've gotten it. Let's see. Okay. God's law. Something?
Okay, sorry, sir. I was not in the last class, so I don't know if you can explain a little bit. Sorry.
Explain it. I said I have x squared plus 4x plus 3. Limit x to 4. So limiting x to 4 means I'm going to use 4 to represent x squared. This is a normal polynomial limit. That's why I'm not simplifying anything. For all polynomial limits, evaluation will always be right for the limit to be obtained. Polynomial function now. This is just a fraction. Look at this. X is to 4. So I'll just use that 4 to represent x. It will now be 4 squared. Told you. 4 squared. So x is 4. So 4 squared plus 4 times x is what? 4 again. Are you getting it? God's law. To work with what? What do you call it? So 4 times 4, 16 plus 3. So now this gives 16 plus 16 plus 3 equals 35. God's law. Did you understand it?
Yes. Thank you, sir.
Okay, now this is another one. That is limit x to 2. And for the function x raised to power 3 plus 4x squared minus 2x minus 3. Please, let's all try this one. And be very fast with it, please. Yeah.
We are not seeing the board very well.
Better look it very well. Means I just maximized it now and I'm seeing it perfectly. Limit x to 2, x squared plus 4, x cubed plus 4x squared. Minus 2x minus 3. I read it from the phone now. We have to be very fast. That's a very big factor. Our exams need speed.
17.
17 from someone.
2. Can check?
Who got 17? Okay, 17. Oh, Mr. Shagun is there. Okay, was that? All right, I've seen 2 people with 17 as their answer. 3 people. Olabi. I don't know why Olabi is good this semester. It's exam time. Still trying to be a serious one. Okay, Aminat, I haven't seen yours. He has done a new league. Naomi, I'm waiting for you guys. Aminat, God's love. B, I think I saw. Who's this? Who got 23? What did you call? What did you got 23 again? Please
I got 17.
What did you want? 17, yeah.
I got 13.
13? Miss Abigail, go again, please. Go again.
It's okay. Not me. Okay. I got 17.
Miss Aloba, Mrs. Aloba, please go again. She won't fight me. It's not me. Let me fight you. I'm waiting for you. A lot to do. So let your mind be here. Any other person, please, you guys are already taking time, please. 23, why now? How did you get 23?
It's 17. I didn't say the question very well.
Okay. All right, I'll assume everyone has done it. So let me quickly do mine. Let's do ours together now. 2x is 2, right? So 2 raised to the power of 3 plus 4 times 2 raised to the power of 2 minus 2 times 2 minus 3. I believe everyone is getting what is happening here, right? So 2 raised to the power of 3 gives 8 plus 4 times 2 raised to the power of 2, 4 minus 2 times 2, 4 minus 3. I have 8 plus 4 times 4, 16 minus 7. So 8 plus 16 gives me 24 minus 7. So the final answer is 17. So the limit of this polynomial to 2 is exactly 17. So for those of us that got 17, we are good with it. Yeah. Now moving to the next thing. Example, I have limit x to 1 in x squared minus 1 over x minus 1. Yeah. So let's give this one a try. X squared minus 1 over x minus 1. Limit x to 1. So this is when you know the essence of what we are doing. That is, why are we doing this class? What do we want to achieve? What do we want to know? This is where you discover it. So I'm waiting for those that are going to do it. Some people will definitely get it right, and some people will get it wrong. So
at least 2 for me.
What do you say?
2. The answer is 2.
All right, you are right. You are right with your 2. Waiting for another person. Who else is there, please? What's that?
Blessing. Blessing. Blessing.
Blessing Okafor. Okay. Okay, 2 is right, 2. Still waiting, please. You're still waiting. Is there anyone else?
The answer is 2. The answer is 2.
All right. But hope you are very sure of your way, the way you got your 2.
Yes, very sure.
That's a very good one. Okay, I suppose there will be some people here that haven't gotten how we got our 2. I mentioned something yesterday. It was difference of 2 squares. Difference, rather, of 2 squares. This is a square, x squared. It's a square of x, right? Minus 1. 1 is also a square of x. When you encounter stuff like this, you are going to use the principle of difference of 2 squares. That means x plus 1 times x minus 1. This is the principle. If I had 4x squared minus 4, it's as simple as simplifying it by writing 2x minus 2 times 2x plus 2. Please take a good look at what I just did.
Yes.
You get it, please? So, that's exactly what's going to happen here. X squared minus 1 is x minus. Because if you use the value of 1 straight, you will get 0 by saying 1 minus 1 over 1 minus 1. See now, 1 squared minus 1 is 0 over 0. So you are going to have 0 or have infinity if you are considering the denominator. So now what we need is just to simplify. That is the method. Simplify first. By simplifying the numerator, we factorize it. It's going to be x minus 1 times x plus 1 all over x minus 1, limit x to 1. Please, are we getting it? For those of us that haven't gotten it before. So now, it is now like this. X minus 1 cancels x minus 1. I have limit x to 1, x plus 1 remaining. So now this is now limit x to 1. Just take your x. 1 plus 1 equals 2. You can see an exact difference between, a distinct difference between 2 and 0. If you did not simplify first before doing it, then you will have a very wrong answer. You have to simplify it first. You simplify, make sure it cannot be simplified further. So please, let's see with an emoji. Is everyone getting it? Like up to where we are now, hope no issue, no problem at all. All right, that's good. Please, let's move. Okay, this is another one. Limit x to 1. I have x, this is where I want to do one extensive work. X raised to the power of 3 minus 1 over x minus 1. Let's see, is there anyone that can give us the answer to this one? I believe you should not come here and come and do 1 minus 1 straight, because you are going to have 0. And that will tell you that there is no limit for it. Whereas there is limit. You simplify your numerator first. Simplify first. So, anyone with that, I'm waiting. Are we saying the question? All right. So I have x cubed minus 1 over x minus 1. Limit x to 1. So what is the limit? Take 2. With this person, you are very fast. Wait. Actually, there 2. So fast. I expect you to go through a process. Please, I haven't done it. I haven't done it. Bye. I think I show.
Yes, I do. I got 2.
Huh?
I got 2.
You got 2. Another person.
Yes.
So fast. I didn't expect you to get it so fast. That's what I'm saying. Naomi, you got 2 too. Definitely there's a problem. Naomi, you two are done with it now. Maybe the 2 you are getting it. How do you get your 2? Oh my. Who laughed now?
I got 0.
Yeah, you all are 0. Where you know the Kingsway waiting I get to. Before we'll do our own together because I don't even know what the answer is going to be. I didn't expect Mr. Shego to have done it so fast. I believe I can't even do it so fast because I have to we have to go for you can share it. If it's not explanation, do it so fast. But I'm explaining. That is so fast. So that was too fast, man. As if you don't see the question, don't see the answer. Too fast, man. No problem. When we do it, we will confirm it's to the answer. That's the first thing. And after that, did you pass through this method? If you did not, definitely you did or you go to the answer. Okay. Still waiting for you guys. Still waiting. Let me wait for maybe 1 minute. Just a minute. Now, let me wait for just a minute. A minute. Anyone else? Okay, I think we are okay. Who got 3? And Amina Tabi?
I got 3.
All right, my bro. Okay, it's good. I think I'll prefer that 3. I haven't solved it, Sha. 3 sounds familiar. Like for the answer, I haven't solved it. I remember we must encounter a question earlier and it was an interesting one. So before you can solve this thing now, I believe you go through polynomial. You never get answer. Oh, Lavi, why you know disturb today? I believe you go through polynomial. So I don't believe, well, I can do it so fast, but I don't believe it could be so fast like that. That was too fast, man. Naomi, that was too fast. Okay, shall we move together now? Please, because of time. Yeah, we'll start. That's what I'm saying, actually. All right. So x cubed minus 1 over x minus 1. The issue is that if I bring my 1 here now, say 1 minus 1 over 1 minus 1, that gives 0 over 0. Anything over 0 is infinity. And considering the top, 0 divided by anything gives 0. So there is a problem there. The limit does not exist. So I have to simplify the numerator first. To simplify the numerator, I will make sure I factorize it. How do I factorize x cubed minus 1? In this thing now, I will let us know one thing we call polynomial because we are going to use it to solve another question. 2. So x cubed minus 1. To solve it, look for what we call factor. In polynomial, we have the factor, we have the remainder, we have the quotient. So look for a factor. How do you look for a factor? What you are going to use as the value of x to give you 0. Using 1 as the value of x will be 1 minus 1 equals 0. That means f of, like that is, let me say f of 1. So 1 minus 1 equals 0. So I'm going to say x minus 1 can be a factor. I'll now use that x minus 1 to divide. You know, we said a factor. A factor is what you multiply by another thing to get a particular number. Factor of 2 is what you multiply by something to give you 2. So now, factor is going to be x cubed minus 1. Let's note what we are doing now. This is what we call polynomial. X cubed minus 1. and x minus 1 as the divider. X in x cube. X in x cube. Guys, I want you to tell me that. X in x cube. X in x cube. From anyone? How many x can we find in x cube? Divided by x cube. Okay. X cube. That's what? You cannot do this one. So we are now coming down. X squared. Please mute your mics, please. X squared times x give x cube again. And x squared times minus 1 gives minus x squared. Come here. So there's something we call an invisible minus here. So minus 1 minus 0 gives minus 1 here. And that minus x squared gives plus x squared. Since x is still here, we can still divide. X in x squared give ordinary x. So x times x give x squared. And x times minus 1 gives minus x. Coming again, x squared minus x squared gives 0 because of the negative that is there. So minus x give ordinary x minus 1. I mean the minus 1 that is there. So x in x gives 1. I mean, so I have 1. 1 times x. 1 times minus 1. Minus 1. So the negative that is there. X minus x gives 0. Minus 1 minus 1. That is minus 1 plus 1. Apparently 0. So I'm going to have 0, 0. That means there is no remainder. 0 is the remainder. This is the quotient. This is the divider. And this is the polynomial itself. So these two things are factors. So since it's like this, I have x minus 1 as a factor and x squared plus x. I'm now coming back to use that thing to represent this limit. X to 1. X minus 1, x squared plus x plus 1 all over x minus 1. So you guys now see that x minus 1 cancels x minus 1. So now I have limit x to 1 for what? X squared plus x plus 1. I believe all of us can do this one now. You have to break it down by simplifying first before that thing is being achieved. So everyone do this one now. What will you get as your answer, please? So Prodigy is the correct person here.
So can we use any other method except this polynomials by division?
No, you can use another method. It's just polynomial. The other method you can use is just your brain, but you'll be able to use your brain after practicing a lot. So maybe you practice very well. So expand x cube minus 1 now is a very simple thing. So, but you have to be practicing first. Once you have practiced it several times, it will be very easy to solve with brain. So expand this brain. What's this?
At least 4. The answer is 4.
No, it can't be 4.
Mm.
X is 1. I will explain again, don't worry. X is 1. So this is 1 squared plus 1 plus 1. Is Abigail? 1 squared is 1.
It's 3. Thank you.
Plus 1. The limit is 10.
It's 3.
So look at this is why I said you won't finish it in just less than a minute when you guys do it. I'm coming back again. Okay, Prodigy.
Maybe when you are done, like I just I'm thinking for the question one of them asks, like, can there be any way? So I don't know if you can just give them a formula to work things like that, if we're having something like that.
Formula, is there a formula?
Yeah, like if you're having the s cube, anyway, maybe s cube minus 1, s cube minus any number, I think we can make it, we can work it as a and b. So it can be a cube minus b cube. So we can work it as, which will be equals to, open bracket, a minus b square, close bracket. Open bracket, a minus b. Are you writing it? Close bracket, close bracket, and open bracket, a square plus ab plus b square, close bracket. Use that formula, it will work too.
The formula will be you'll be able to use the formula now. But this is how they got the formula too.
That's what I'm saying. Yeah, for them, so that they can climb the formula.
Okay. Famous rule. I beg when I cram formula. They say you guys should cram the formula. I don't even know something like this exists. It's just the form. It's like saying formula. It's like saying a plus b squared equals a plus b times a plus b. Or saying a plus. It's just like something like the difference of two you mentioned earlier. So you can, for those of you that wants the formula this way, you are looking for a method, a shortcut. Take this formula there. So and keep it because we'll still use it tonight. So this is established, right? Take this formula. It's just that ideally it's not a formula, but it's a form. It's okay. So it is okay. The recording will stop here. Okay. Okay, thanks, mate. All right. So now since we have that known, note that method. He said a minus b. Maybe is going to save us the stress times a squared plus ab plus b squared. So we are going to use another example now. This is difference of two cubes. That's how this exactly the formula for difference of two cubes. So so I didn't want to talk towards that side before. So x cubed minus 8 over x minus 2. So let us say and x equals to 2. X equals 2. So is there anyone that can give this one a try now? Mr. Shegun and Naomi. Is there anyone that can give this one a try now? Yeah, please, anyone? Are we trying it already? Okay. All right. Is there anyone trying it? Don't forget. What do you say? 12.
12.
Okay, please hold it at the moment. Keep the 12. Let's see. I don't know at the moment.